Hello friends, today I will discuss the cost of electrical energy. So for this, some mathematical analysis has to be done before it is to be taken into account. So there are three types of costs involved while generating the energy from the generating station. So they are nothing but fixed cost, semi-fixed cost and running cost. And these items should be known perfectly to calculate the optimal value of electrical energy per unit. So fixed cost here means it is the cost involved independent of power generated and power demand. So they are nothing but capital cost of the land, interest and salaries to employees. These three comes into the category of fixed cost. Semi-fixed cost. This cost involves with maximum demand and it is independent of units generated, and maximum demand determines the size and cost of installation. Size of installation determines the electrical staff and the taxes on the plant. So that means semi-fixed cost involves or depends only on the maximum demand and it does not depend upon the generated energy. Next, running cost. It is the cost involved with the number of units of energy generated. So it depends upon the energy generated by the station. The running cost depends upon the annual fuel cost, lubricating oil, maintenance, repairs, and salaries to the staff. To get the mathematical expression for the cost of electrical energy, the three parameters fixed cost, semi-fixed cost, and running cost will be taken into account. So while taking these three, there is a classification for finding the expression for the cost of electrical energy, that is a three-part method. The other is called the two-part method. In the three-part method, three parts will be there, which first letter indicates the fixed cost and second letter belongs to the semi-fixed cost, which depends upon the maximum demand, and whereas the last one parameter depends upon the running cost and it depends on the energy generated. So then these three parameters are mentioned like this: small a plus small b into kW plus c into kWh. So here a means it is a annual fixed cost independent of demand and generation, and b depends upon the is a constant which is multiplied by the maximum demand, whereas c is the constant multiplied by kWh generated per annum. So in the three-part method, the cost of electrical energy is equal to in rupees A plus B into kW plus C into kWh. Here A belongs to the annual fixed cost, B is a constant which is multiplied by the maximum demand, and while C is a constant which will be multiplied by the energy generated per annum. Next, there is another method of finding the annual cost of energy that depends upon the annual cost of fixed sum per maximum demand. The other is running charge per unit of energy. So in the two-part method, the total annual cost of energy is equal to capital A into kW plus capital B into kWh. Here, capital A is a constant multiplied by maximum demand in kilowatts. So this includes fixed value also in this A, and B is a constant multiplied by the annual kWh generated, means energy generated. So using these two methods, the cost of the energy will be calculated. Using these two methods, that is three-part method and the three-part method, first the total cost of electrical energy generated will be calculated, and then the total number of units generated will be taken into account, and then the total cost of the energy generated divided by the total number of units generated will give the cost per unit power generation. Now let me take a numerical problem for calculating the per unit energy cost. Here a generating station has maximum demand of 50 megawatts with the following data. Determine per unit cost from the data given. So here the capital cost is 95 into 10 power 5 10 power 6 rupees, and annual cost of fuel and oil is rupees 9 into 10 power 6, and annual load factor is 40%. Taxes, wages and salaries etc. amounts to rupees 7.5 into 10 power 6, and interest and depreciation is 12%. So having known the definition of fixed cost, the semi-running cost, having known the fixed cost, semi-fixed cost and running cost and the various terms involved in them, it is possible to solve this problem in two steps. One is number of units generated per annum. The second step is cost of energy generated per annum. We know that load factor is nothing but average load divided by maximum load, and that average load can be written as average kWh generated per annum divided by 365 into 24 into 1 by maximum load. So from this, the units generated per annum, average kWh units generated per annum is given by maximum demand into load factor into hours in a year. So maximum demand is given as 50 into 10 power 3 kilowatts, and then load factor is also given as 40%, means 0.4. So into number of hours in a year, that is 8760. After simplification, we get 17.52 into 10 power 7 kilowatt hours or units. This is the energy generated per annum. Now, what is the cost to generate this number of units? So to get that, we should know here what is fixed cost, what is running cost. So annual interest and depreciation is equal to 12% of capital cost. This is given in the data. So from this you can calculate what is annual interest and depreciation. That is 12% means 12 by 100, that is 0.12, and capital cost is already given in the data, that 95 into 10 power 6. After simplification we get 11.4 into 10 power 6 rupees. annual cost. Next, annual running charges. So, this is nothing but annual cost of fuel and oil plus taxes, wages, etc. And annual cost of fuel and oil is given as 9 into 10 power 6, and taxes etc. is given as 7.5 into 10 power 6. So adding both, we get here rupees 16.5 into 10 power 6. This is the total running cost. This is the total fixed cost, that is 11.4, and adding both, that is fixed cost and running charges, we get here 11.4 into 10 power 6 plus 16.5 into 10 power 6. And after adding these two, fixed charges and running charges, we get total annual charges as 27.9 into 10 power 6 in rupees. Then, having known the annual charges for the whole year and the number of units generated per annum, we can calculate the cost of unit is equal to the total number of the annual charges for the total energy generated divided by the total energy generated. So after simplification, we get here, that is 27.9 into 10 power 6 divided by 17.52 into 10 power 7 will result in 0.16, that is 16 pies. So let me summarize once. We have seen what are the costs involved while generating the energy, that is fixed cost, semi-fixed cost and running charges. And also we observed that there are two ways to account these costs, that is fixed cost, semi-fixed cost and running charges. Those two methods are nothing but two-part method. The other one is three-part method.